Okay, welcome everybody. We're here this afternoon to discuss the exciting topic of problematic and hazardous waste. We have a great lineup of speakers and some really fantastic expertise. Unfortunately, Rob Hogan from the New South Wales EPA's not been able to attend due to a personal matter he had to attend to at home. So we're going to have to fill his very big shoes and to cross over possibly into some of those regulatory issues, and certainly we'll welcome input from the audience on that topic as well. Obviously we've been sort of moving around these issues for the last couple of days, and I think some of the things that we would like to draw out are really some of the key issues around, what is a problematic waste versus a hazardous waste, and some of the definitions around that, and particularly how it varies from state to state. Waste classifications obviously are very important in this space. Also, some of the things that are occurring because of the changing risk profile of different products, and batteries in particular being a key one, and how that impacts the management of hazardous waste and how we need to work to manage risk in that scenario. And then emerging products like vapes and other things that are definitely coming onto the scene from a local government perspective as well. So we might get started, I think. So our first speaker of the day is Zoltan Sekula from Ecobat and Ecocycle. Has a wealth of expertise in this space, and looking forward to the conversation. Thanks, Zoltan.
Okay, allow me to introduce myself. So my name is Zoltan Sekula. I work for a company called Ecocycle. Ecocycle is a group of companies consisting of 6 different companies as such. One of our subsidiaries, Ecobat, which provide a majority of the household battery collection points around Australia. I just outlined pretty much what the organisation does. We do multiple hazardous waste categories: mercury recovery, lighting, bearing waste, X-waste, e-waste and batteries. Headquarters are in Melbourne. And what I will demonstrate at the moment on what infrastructure has been put in place at the moment to deal with the mixed household battery issues we have and embedded products all over. So we have a strategic focus on post-consumer batteries, and we provide full service from the deployment of the collection bins, collection, transportation and the processing of the batteries. We have public battery collection kiosks pretty much at all major supermarkets and hardware stores, and a lot of the LGA facilities like libraries around Australia. All our equipment is UN approved and AGD certified. So we have specialist transport vehicles, battery collection bins and also bulk battery transport containers. The network creation ultimately has to provide convenience to the consumer. It is very, very difficult to motivate the general public to bring their batteries unless it's very, very close. Hence the idea of rolling it out in supermarkets and hardware stores. Everybody goes past. We don't put a limit on the batteries that you can bring in, but I would suggest don't store your batteries and send a message out there. So don't store your batteries endlessly at home. Right? Bring them in every time you go to the supermarket. It provides a much safer profile for everybody. The product groups that we accept are all batteries. So from loose batteries to embedded batteries, it doesn't really matter on what it is in. The battery stewardship certainly has a category of the batteries that are coming through their system, but we're also working with the NDCRS on e-waste and process all e-waste that's being donated by the public. The range of equipment and battery size that we do, we start with household batteries, which are the relatively small batteries, and then go over to energy storage, electric vehicle, micromobility, and the EV, the PEVs, and all the other EV variation batteries that are coming through. We have industrial solutions for LGAs, transfer stations, landfills, MRFs, for example, and we operate an automated battery sorting process in Melbourne. which is AI-driven and allows the various chemistries to be separated so that we can batch process the batteries and recover the resources thereof. Certainly, we are active in supporting the Recycling and Waste Reduction Act, regulatory reform that's going through. We focus pretty much on education, Minamata Protocol, Battery Stewardship Council, the National Television and Computer Recycling Scheme, overall trying to embed circular economy and trying to get towards the 80% of all waste to be recycled by 2030. And we're involved with the ADG and Australian standards for fire protection equipment. One of the big issues that we currently have with lithium-ion fires is that there is no dedicated lithium-ion fire extinguishers that are approved to Australian standard. There is no Australian standard under AS 1841 for lithium-ion batteries. The fire protection industry has sort of let it slip, and I have to point the finger because the batteries have been around for quite some time, and it's only now that work has started on AS 1841 for lithium-ion batteries. When you look at your battery fire, when you look at the fire extinguishers that you have currently, the classification for lithium-ion battery fires is a Class B fire. So your fire extinguishers that are categorised for A, B, and E or C fires, depending on what you have, are going to be okay to bring your fire under control. But the issue with the current fire extinguishers is that it does not stop the battery from reigniting. So the first thing that you need to do to a lithium-ion battery is to cool down the battery to stop the electrolyte and the gasification and stop the thermal runaway that's in progress. So should you have a lithium-ion battery fire and you put it out with a fire extinguisher, try to put it at least into a bucket of water before you put it anywhere. Okay, and then wait until it stops bubbling. That would be an indication that the chemical reaction has actually stopped. At that stage, the battery becomes safe. There's battery safety sleeves that are available. Put it into one of those and then you can send it off for recycling. So currently the network for household battery collections is about 6,500 locations. Some are public, some are not. But the distribution is right across Australia. So as far as your local government is concerned and their residents, there should be a solution for all the batteries very, very close to their supermarkets and hardware stores. We can see every battery. We can see every battery collection bin on a software platform called Superfire. We can access the sensors which are depicted here that are sitting inside of the actual cabinets, and they monitor the fill levels, the ambient temperature of the battery bin, gives also some statistics on the collection volumes and the GPS coordinates of that bin. So where this is being used is to try to automate the whole collection process. It doesn't involve anybody to get involved. We can see the fill levels coming up every morning. It does the automatic routing and brings in efficiency to the system to minimise any delays. We certainly can see any unexpected heat events that may be detected. And there's a hard limit on the sensors of 60 degrees. If there's anything happening, we actually set that software-wise at 55 degrees and can adjust that for air conditioning environments. So should there be a thermal event at any of the collection locations, the system will send out an SMS to our group and also to the nominated contact people at that particular site to try to take some action. You generally have some time before anything happens. Generally, you can see the smoke coming out of the bin if there is anything happening, but also it smells. So people generally pick up on the smell. Button cell batteries, can go off. It has happened once so far, and you won't be able to see the smoke or the fumes, but you're going to be able to smell the actual lithium burning. So we provide solutions Australia-wide. These are the battery collection kiosks with various brandings that are out there for consumers to use. These are all UN approved. The current two bins next to it are the new metal bins that are coming into the country from about Q3 in this year. The difference between the two units is there's a plastic UN-approved container in the kiosk, and they're going to have to be replaced sooner or later with the steel containers. The steel containers are manufactured in Europe and have special acrylic coating on them, which adds to their fire resistance nature. So it's very, very unlikely that any fire caused by a battery is going to be able to break out of the metal drum. The lids have been configured to be extra safe, so you won't be able to, as you can see, that big chute over there on the battery kiosk will accept large batteries. The new bins that are going to be standalone in the retail environment are specialised. The holes have been restricted, so pretty much your 9-volt battery is going to be the biggest battery you're going to be able to put in there. The idea will be to reduce the risk profile at retail, or the perceived risk profile at retail locations, and then roll out industrial solutions at all the transfer stations to deal with any large batteries, or you have to go to your tool shop where they will accept the tool batteries or e-bike batteries at the stores. So the system has been up and running now since 2020. It's successful, and as I mentioned, we have had one battery adverse event happen to be in Iluka here in New South Wales over that period of time. And when you take a look at the Battery Stewardship website, there's a lot of information regarding the safe handling and the disposal of the batteries. The easiest way to protect anything happening with the batteries is to tape the terminals. We can accept sticky tape, electrical tape. The sorting machine doesn't like it necessarily, but it's secondary to what we're trying to achieve. Is if 9-volt batteries are taped, if button cells are taped, right, then you're going to have less likelihood of any adverse events. It's very difficult to explain to the public which batteries should be taped and which shouldn't, so the policy is tape all. You know, it would be nice if that would flow through. From our experience, the take-up is fairly slow, you know, changing behaviour, and people will get there with a bag of batteries and, you know what, you can't spend another 20 minutes doing it, right? So we get the batteries as they are. But the hope is that with further education and raising awareness, that is going to start flowing through. None of the batteries are actually dangerous at the point of disposal if they have been discharged. So in that particular event in Iluka, what happened is somebody decided to get rid of a bulk of button cell batteries, the silver cells, and dump them into the bin. Somebody else came along and went along the beach and picked up all the old batteries that were falling apart. And as it happens to be, at the right moment, right, one of the ends of the battery shorted out one of the button cells, and we had the fumes coming out of the cabinet. Nothing happened, stood on the side, nothing was damaged, but it's a concern for retailers, and we need to impress on the public that the only way this is going to be able to continue is if we're going to be able to keep the risk profile at an acceptable minimum. And while it's reliable, there is issues, for example, with mobile phone repair guys, and I don't want to single them out as not being interested in what has to happen, but when you go and get your mobile phone repaired, to get the battery out, they need to actually pry off the lithium-ion battery from the actual case. At that stage, if the battery gets punctured or crushed or receives any other damage in the process, that battery, in theory, could go off anytime. It could be tomorrow, next week, in 3 weeks' time, nobody knows. Batteries store... Oh, let's go to the safe storage first. At our facility, we need to store the batteries separately from everything else, right? So at MRFs, transfer stations, landfills, lithium-ion batteries should be kept away from any other combustible material as such. In an industrial setting, we're using 40-foot containers. Batteries come in, they get sorted. There is systems built in that monitor the temperature within the actual containers. There's fire extinguishing propellant in there as well. So in our yards, these containers are separated from everything else. Should there be an adverse event, there's procedures and monitoring in place to raise the alarms and a response that can be explained later on. To provide the safest way of transporting large batteries and enable the recycling so that we don't have the argument with government that you can't do anything about this until the infrastructure is built. Well, the infrastructure has been built. Now it's a matter of motivating the public to return the batteries. So for large batteries and battery collections in bulk, you may have seen the bulk containers that are outside at the front entrance. The galvanised bins are the bins that we're rolling out at no charge to most transfer station and landfills. As long as the bin turns over on a regular basis, right, we don't actually have to charge for the rental of the bin, right, at the current stage. The bins come in 900 and 600 litre versions, so you can put in there anywhere between 500 to 900 kilos of batteries, depending on the mix. We have plastic liners that can go into the bins, But galvanised steel as such is not a good conductor, so you have to be relatively unlucky if one of your batteries has gone short against the wall. But we offer the plastic liners if you want to use them. Underneath there, that's an EV storage and transportation bin. So in case there is an accident with an EV, the biggest problem at the moment is to ascertain what damage has been done to the battery. Generally speaking, if the car has been in a reasonable accident, that battery is now deemed unsafe. If there has been no fight, it will get towed away with a tow truck. It goes into a holding yard. Sooner or later, that battery has to come out. We can't actually transport that battery anymore. It has to receive a crate to put it in. That crate is filled with fire retardant or with vermiculite or the Cell Block X product to ensure that if there is an adverse event, the fire is contained and it's put out before it actually becomes a real problem. We also have EV transport containers. These are 20-foot containers that have been fully equipped with fire suppression equipment and obviously a tray. So should an EV break down, if it has any problem, if there's any concern, we can certainly roll these out and the vehicle gets towed into the 20-footer and then the tow truck can take it away. It's fully monitored, it reports temperature, it has fire extinguishing agent in it. So what happens to the batteries when they land at our place? So the separation process is fully automated. We put them in, it goes onto a conveyor. It has various technologies to separate the actual materials, from magnetic to optical sorting. It does size sorting as well. So you come up with about 15 different streams of batteries, and then that gets accumulated and processed separately in a batch because the chemistries in the black sand, or the resource I'll explain later, that comes out of it is only valuable when you don't contaminate it with chemistries that are not compatible with it. So what it looks like in real terms is this is the machine. It takes up most of the factory and it's fed on the right-hand side, it goes through various conveyors and separation technologies, and underneath the chutes, that's where the batteries come out. So it separates the waste, mobile phones, tablets, and then it goes into the batteries. And in the end of this side, where the blue little baskets are, that's where the button cells come up, and they're sorted as well. So in the end, all the batteries, once they have been neutralised, go into a shredder, and it does the magnetic separation and plastic separation. And what we end up with is what's on this side, it's the black sand. So the black sand is the carbon black that sits within your battery, and that contains the lithium, the cobalt, aluminium, or the copper, anything, the manganese, and that goes down for further processing into hydrometeorology or pyro to retrieve the actual elements themselves. Oh, this is just a little chart of all the chemistries that are coming through. So, when we process lead acid batteries, it's obviously not good to mix them with lithium batteries, right? And then we have certainly the silver cells. They have to be refined separately to be able to recover the silver. Alkaline batteries are very straightforward. What comes out of is the zinc compound and the manganese, which can be used in fertiliser, but obviously we don't want any lithium or cobalt in that material to go out, so the lithium batteries have to be processed. Nickel batteries that come through, if they're nickel-cadmium batteries or nickel metal hydride, it's a separate process. So the importance about this is that we need volume. Okay, this doesn't work if we're going to continue, collecting the volumes that we have. The current collection rate is about 12%. We have a little while to go. The infrastructure is not going to stop us. It's the motivation of the consumer. Now, might as well. So the consumer, the ACCC has approved for the consumer to pay a levy. So pretty much when they purchase a battery, the recycling process should be, in theory, paid for. So there's no added cost to the consumer. We just want their batteries. And yeah, some of our credentials, and I will leave that on the slides. Now, battery recycling and the risks thereof. You probably have heard about all the fire incidences that are currently being recorded. Larger batteries, EVs that catch on fire, micromobility scooters tend to catch on fire, and e-bikes. The reason why micromobility devices are having such a poor performance really is not necessarily the battery technology is bad, but if you throw these batteries around and you do tricks on your e-scooter or take them through a physically abusive process, you can actually damage the integral part of the batteries. And it will start off with micro cracks, stuff that you can only see on the microscope. But because batteries store energy in chemical format, the leakage between the polarities, right, expands that crack that has developed, and it just starts growing. And as it grows, it heats up and it gets bigger. And eventually, right, it breaks right through as a short circuit. That's when the battery goes into high heat. So what I wanted to show here is, this is one of Libby's reports. Currently, the belief is that there would be about 30,000 tonne of batteries out in the market that are placed onto the market. If we take out the lead-acid batteries of, let's say, 4,500 and the unknown, the specialty batteries of 210, there's about 25,000 tonne of batteries that enter the market. Now, the waste arising is believed to be somewhere around the 19,500, total scope, 21.7. I thought it was 19.7, but it doesn't really matter, right? We have a long way to go. There's more batteries coming onto the market that are being recycled, and they disappear in landfills. So at the moment, about 80% of batteries believed end up in landfill. Now, when it comes to thermal runaway, the biggest problem we have is the mechanical abuse process, right? Now, consumers not knowing any better, they see the recycling symbol on their batteries, right? Obviously must go into the recycling bin, right? Yellow bin is closest. Like vapes are recyclable, right? Let's put them in there as well, and keyboards and mice and, you know, all the toys and everything else, because it has a recycling symbol does not mean it should go into the recycling bin. When it gets into recycling bin, the likelihood of it getting crushed in a compactor is extremely high. So currently, the guys who are here with compactors are telling me that they have at least one fire a day in a compactor. At a MRF, we have about 3 fires a week. At landfill, I think they have stopped counting how many fires a week are happening. So mechanical abuse, electric abuse only happens when you have your unit on charge, and it has been abused, right, like with e-scooters. During the charging process, things can happen because on one of the slides I'll show you how it's constructed. The thermal abuse happens when you put, for example, the wrong charger onto a battery device. It doesn't know when to switch off, and it basically overheats the battery. Lithium-ion batteries get really touchy about 45 degrees. And if you get them to 80 degrees, there is no stopping. It goes into a thermal runaway, and it develops very quickly. So I've shown here the various chemistries. A lithium battery means not much to us. There is various subfamilies under the lithium category, and some are safer than others. So you may find that nickel, cobalt, aluminium batteries are mainly in EVs, right? Then we have the nickel manganese cobalt batteries. Now those batteries have been adopted in most mobile phones, and that's because the battery can be made smaller, and it has a higher energy density for the weight and the size that it can deliver. So if the charger is working properly, and most mobile phones, for example, do work very efficiently, but everybody remembers the little Samsung saga, right, where the mobile phones caught on fire. Mobile phones are extremely safe, right? As long as you use the charger and the charger is working fine within the limits of the charging that the manufacturer has dictated, we don't expect any mobile phones to go off in the household. The recommendation is don't put them in your pillow when you go to sleep, right? It tends to overheat, or it could overheat. And if you can, don't leave your mobile phone on charge overnight. Guilty, right? It's just not possible. So industry is suggesting, so, you know, you could use a metal box. There is charging sleeves that are available. Put your charger and the battery in there, right? If there's an adverse event, right, it's going to contain it at least to a level where the fire alarm is going to go off and you get time to exit the house. So the problem we have with batteries, and this is just a typical battery design. It comes in standard prismatic. Oh, sorry. Okay. So that's a typical battery makeup, and what you can see at the moment is on the bottom half, you know, we have the separators and the anode, the cathode, and all the technical stuff behind it. But on top, near the positive terminal, right, you can see the fuse. And then there's a little controller, and then there's the negative terminal. Now, the problem with the lithium batteries in general is that the fuse can only see any events that are past the terminals. So anything that's being fed, anything that's hooked up to the battery is protected by that fuse. If you have something happening within the battery cell and it has been physically damaged and there's a short circuit developing, that fuse is not going to help us. Okay? When a battery has suffered physically, generally at ambient temperature. The temperature starts rising, and at the moment we have a timescale on the bottom. So about 400 seconds before you're going to have real trouble with that battery. Okay, so 6 to 8 minutes, give or take. And what happens, the internal temperature in the battery will rise. It will go about 80 degrees approximately here. And then it will continue rising until it reaches critical mass, and you will find that the battery is probably gassing at that stage, so it expels the electrolyte and a number of other gases. And at that stage, the temperature will jump, okay, from 120 degrees to near 600 degrees, plus or minus a couple of hundred degrees. At that stage, the battery is going to be on fire. There is nothing you can do unless you can cool that battery down to stop the thermal event. It will only be lasting relatively a short time, depending on what state of charge that battery had and how big the capacity of that battery is. In a household piece of equipment, you know, it should be over and done with within 2 or 3 minutes. Where the risk is, for example, when you have battery packs, and I'll pick again on the micromobility market, or tool batteries have generally 4 to 6 different batteries within the pack. If one of those batteries takes off and has a thermal event, and if you follow the red line, that would be the first cell that went off, and that's number 5 in the centre of that test setup, that battery will exert enough heat right around it to engage other batteries and drop them into a thermal event scenario as well. And it progressively runs through the battery pack, just like a bad apple would be in a normal bag, and it will not stop. Okay, it will not stop until all the energy within that pack has been put on fire, pretty much. Should you have a thermal event with a larger battery pack, okay, the best way obviously would be, or the recommended way at the moment by fire and rescue, is to put it into a bucket of water. I cannot actually recommend to do that. Handling that battery at 400 or 500 degrees without knowing at what stage the thermal event is, it could actually explode right in your hand when that happens. Okay, so it's better to evacuate, get out, call the fire brigade. Yes, there will be a lot of damage, but your safety is ultimately more. Sorry. Ultimately, the fire brigade will take care of it. There will be a lot of damage to the premises, but safety comes first. So don't try to handle the battery unless you have proper gloves and you know at what stage the thermal event is, otherwise it could explode in your hand. A couple of stats from Fire and Rescue New South Wales. So this is only New South Wales related. There's an ABC report, they have done the stats last year, I think it was March 17. So they came up with approximately 1,000 events over the last calendar year. New South Wales has a research arm at the moment that has a very close look at lithium batteries and fighting lithium batteries and EVs. And these are some of the stats. So over the last 2 years, 22-23, as you can see, there's 456 lithium-ion battery incidents that were recorded. Now, number of people injured, fatalities, and that has now increased, I believe, to 3. Evacuations, 2,149 evacuations. So the social cost to lithium battery events is very high. Now, if you take a look at the response time, we are tying up fire and rescue with an average of 104 minutes for every event that's happening. Okay, that is an unfortunate cost to society, where really they should be attending to major emergencies. Their statistics indicate the biggest culprit at the moment, or the biggest risk factors, are e-bikes, e-scooters, and now these toy cars. I don't have any details, you know, obviously it's accounted for, but the e-bikes and e-scooters, because of the physical abuse that they experience potentially, we believe that is the main cause for the batteries to suffer. The price value proposition by a lot of companies, there's a lot of stuff coming into the market that not necessarily is made by known brands. Price is everything, so you might want to check the approval ratings on the equipment and make sure that they have been properly tested and verified. Never, ever try to swap chargers on micromobility, right? With the different chemistries that I was showing on the other slide, the requirement for the charging is also different. So just because the voltage matches or the plug fits into the same connector does not mean that that charger is compatible with that unit you're trying to charge. And that's pretty much for everything. So your reaction of the battery in a thermal event will depend on the state of charge. So a battery that has been fully discharged is pretty much safe. Most of the time when people dispose of their equipment, the last time they try is to give it another charge, right? So in the waste cycle, we see a lot of batteries that are half full, three-quarter full, or even full. Just because the equipment doesn't turn on anymore doesn't mean that the battery could not be charged, and you won't know. Okay, you throw it in your recycling bin inappropriately, it will get crushed or likely get crushed. This is further analysis. So for the waste industry, the fires that were attended to, the stats are really there. Now, lithium in waste receptacles, right, while the percentages are relatively small, the cost of those incidences is extremely high. So lithium batteries in waste trucks, right, you could lose anywhere between $150,000 to $500,000 on a truck, right? If you can empty your truck roadside and you can get rid of the load, you will save your truck. If you happen to be somewhere where you can't get rid of it, the combustible material in the truck is going to catch fire. You can look it up, what happens. So the important part out of this is that lithium batteries, or all batteries, should really come out of kerbside. We need to make sure that the public understands that there is infrastructure in place. They can take it to a supermarket or hardware store. At that stage, the batteries are safe. They have not suffered any physical abuse. Put it into our bins. We can see the collection levels, we can see the temperature of the bins, we can react, we can empty them at the right time. So, a demonstration of what happens. Oh, let me just see. This should have started automatically. Oh, yes, please. So this is your standard 1860-50 battery, and we're simulating a crushing of the battery, or maybe not. No, it doesn't want to load. No, that's all right. Scott, you have videos, right? Okay, so we can skip this. Anyway, this is only a small battery, right? But the intensity of the fire is significantly large. Scott is going to be able to show you some details on the next presentation. So if you have any questions, there's certainly lots of material, lots of discussions that we could have. Our display, I'd say, obviously has, bins and fire protective equipment, risk mitigation processes. We are available, right? And there's a lot of information available on the web anyway, but please do give us a ring. Thank you.
Thanks, Zoltan. If nothing else, I think that has us all going home thinking I shall never charge the phone on my pillow again. Lots of important issues to discuss there, and I think we'll wait till the end and bring everybody up on stage. Next, I'd like to invite Scott Russ to come up. He works for Wastech Engineering, General Manager of Sales and Marketing. Wastech's an industry leader in the provision of best-in-class products for dealing with the issues that we've just been looking at. Thank you.
Good afternoon, everyone. Firstly, I'd like to begin by acknowledging the traditional owners of the land on which we meet today. I'd also like to pay my respects to elders past, present and emerging, and also thank you to the event organisers, Connie and the Impact Enviro team. Just to give you a quick overview on who Wastech Engineering is. Wastech are a leader in consultation, design, developing and manufacturing equipment and facilities for the waste management and resource recovery sector of Australia and New Zealand. Wastech have been in business for 30 years in Australia and are proud to still manufacture within Australia while partnering with global brands, as you can see from some of the logos behind me, bringing the latest innovations from around the world. Wastech is an industry leader in the provision of best practice, in-class products and services to the resource recovery sector, and in 2022 we partnered with Fire Over USA as the exclusive distributor in Australia and New Zealand for their early detection and fire suppression system called FireOver. I'm excited to be here today to talk in more detail about the risks to our industry, and I believe needs to be at the front of our minds, the risk of lithium-ion batteries and waste and resource management. As we are all aware, our industry is high risk, from receiving and handling waste, moving plant operational equipment, dangerous waste streams, contamination of recycling streams, and unknown incorrectly disposed of products. Lithium-ion batteries are the unwanted visitor. Small, powerful, unseen, and always likely to self-combust. As these batteries contain a flammable electrolyte fluid, they become pressurized and dangerous in a range of circumstances. Then there is thermal runaway, as Zoltan spoke about earlier. This occurs through thermo or mechanical failures, overheating, impact, and the incorrect use. When this process occurs, it results in the high temperatures that produce an exothermic decomposition of the battery cell, and this leads to the battery rupturing and creating a thermal explosion. According to the Hazardous Waste Infrastructure Needs and Capacity Assessment reported by the Department of Climate, Environment, Change, Energy and Environment and Water, the surge of lithium entering the waste stream in the years to come is a particular concern. The report estimates that waste lithium-ion batteries will grow by upwards of 300% each year by 2036. That's a staggering number. The results is a generation of between 100,000 to 187,000 tonnes of waste per year. Phones, laptops, rechargeable batteries, kids' toys, e-scooters, as you could see on Zoltan's presentation, is number one on the list. Portable medical mobility devices, the list goes on. We also have e-cigarettes growing in excess of 58 million users a year. Then there is the increasing risk of lithium-ion batteries within the millions of disposal vapes that could be recycled that are ending up in landfill across the world, especially in Australia. Yet they contain lithium, a metal high in demand. Roughly 1,200 electric vehicle batteries could be made from the lithium discarded in vapes and cigarettes, e-cigarettes, in 1 year. In the absence of recycling, vapes and e-cigarettes pose a serious risk. Impacts may include the leaking of aerosol, transport of toxic substances from e-liquids, the leaking of corrosive electrolytes from batteries, the leaching of heavy metals from batteries, and of course, fire caused by lithium batteries. As you can see from this graph behind me, the additional risks that e-cigarettes are bringing into the market worldwide. Asia Pacific is the fastest growing region, unfortunately, which we sit in. These products are branded as rechargeable and disposable electronic pod, not great for creating an environment for recycling. And with little to no product stewardship or recycling initiatives, we have a lot to do to reduce the risk. To make matters worse, we are also well behind the rest of the world with recycling of lithium-ion batteries. Although it is old data, and we have been improving our battery recycling in Australia of late through great initiatives like EcoBat, as Zoltan talked about earlier, and other means of recycling, Australia has a long way to go, and product stewardship is required. Just imagine, with the predicted continued growth in the production of the product, we will continue to see increases in the risk of our facilities and operators. Lack of legislation, prevention and recycling, we will continue to see a dramatic rise in fires. We need to do more to educate our consumers when it comes to recycling and disposal. And does lithium-ion batteries contribute to the risk of fire? Causes of fires in waste management and resource recovery facilities. The more and more we talk with transfer stations, MRFs, and other recycling facilities, the more we hear about the constant battles with fires that is a daily occurrence at a lot of these facilities. And there's heightened risk when paired with climate and the stock that we hold. A report released by the Victorian Government titled Fires at Waste and Resource Recovery Facilities in December 2022 outlined, across 208 recorded fires in Victoria over a 4-year period, up to 57% were attributed to lithium-ion batteries as a possible cause. Speaking with operators in transfer station MRFs across Australia, there are sites experiencing multiple fires per day, per facility, due to the same cause. It is important to note that the amount of reported fires was 208 across 4 years. We are unsure of the unreported numbers of fires. Also, numbers provided by our fire-over colleagues in the US, for an example, as you can see from this image behind. An example of a very large MRF in Columbus, Ohio in 2022, had 70 fires, and of those 70 fires, 66 were battery-related. Reported fires, and reiterating the point about unnotified fires, we are unsure of the actual number of fires, data provided by Insurance Office of America from 2016 to 2018. The number of reported fires is strikingly similar to the number of fire insurance claims numbers supplied by the Insurance Office of America in the same period. Some numbers we've obtained through talking about the risk of fire is that sites are experiencing multiple fires per week, and some due daily to lithium-ion batteries. And the feeling is that it's only a matter of time that we have a catastrophic fire event without faster response times and protection. And the fires keep coming across Australia. More and more truck and facility fires are being traced to lithium-ion batteries, placing our sites and the public at risk. Imagine the impact of waste trucks dumping the full load on our streets. The other products we are handling might play a part through heat, combustible material, and accelerant. But the highly flammable, high-temperature thermal runaway and the increase in lithium-ion batteries supply makes these fires more frequent and harder to get under control. Here is an example that I wanted to show you, and I'll start the video, of how fast the lithium-ion battery fires can start and how thermal detection, human verification, and intervention via fire-over can make a huge difference. According to the Materials Recycling World Survey published in September 2018, nearly 75% of respondents said fires caused the business to shut down for 1 or more days. So it's a large commercial impact to any business. Cost to the industry. Continuing on, according to the Waste Industry Safety and Health Forum in the EU's expert guidance, a successful fire incident outcome is 4 hours. Where there is a gap in response times, the severity increases greatly and causes significantly more damage. Almost 80% of the fire incidents in the UK burn for 4 hours or more and burn up to 50 tonnes of waste and recycling material. Looking at the figures based on reasonable assumptions, lithium-ion batteries unfairly cost waste, recycling and scrap operators in the US and Canada over $1.2 billion annually, $2.4 billion collectively, and over $400 million in Australia every year. Fortunately, in the UK, France, and now Australia, fire-over is now available to those markets to provide 24/7, 365-day fast response times. And what is the cost of insurance? These are the figures out of the US via the Insurance Office of America again. We're reliant on a lot of data. We're still in our early stages in capturing data in Australia in regards to fire and fire over. But again, they confirm what we hear about insurance in our industry. Insurance is hard to get. It's expensive, in some cases worth the risk of not obtaining. A lot of waste companies are self-insured. We have fewer companies willing to insure. The options are limited. As you can see from the graph behind, the risk by the insurers versus the effects of the premium is quite significant. We've worked with a number of customers in Australia that were not able to get insurance until we actually activated and turned on and went live monitoring with the fire over system. Some of these operators had a $10 million investment that they were sitting on, waiting for our fire rover service to be turned on before an insurance company would insure them. Now let's look at the fire development stages. Fire development stages. We all know that within our industry the risk of fire is more than likely always going to be there. Heat, self-combustible material, high-risk products, accelerant, more than enough fuel, and the risk of lithium-ion batteries means far too frequent hotspot fires. Fire protection is about the detection, verification, and fast response times. There is no silver bullet to avoiding fires. We need to suppress and slow the progress and put them out fast. Bless you. Now let's look at Waste Management US facility that wasn't able to act fast enough. Here is an example of how a spot fire can grow quickly. I'm sure we've all seen and heard about these blazes. Let's hope we never have to face one. Without thermal detection, human verification, remote intervention, the result can be catastrophic. Fire Rover can do all that for you, being the first respondent within seconds, while the site and authorities are alerted and can react. So we need to look at a multi-pronged approach. But we know that prevention isn't always going to happen. There is no silver bullet, as I mentioned, to avoiding fires. A multi-pronged approach starting with a fast response is the next best option. Do all required to eliminate or slow the progress. Identifying the changes in heat through military-grade thermal cameras, human intervention, and remote human intervention. This is what Fire Rover can provide. So let's have a look. Watch as the military-grade thermal camera identifies the increase in heat, human verification by the high-definition camera, and intervention via the cannon using an F500 encapsulating agent, which is environmentally friendly and non-PFAS, and water combined. With F500 mixed in with water, the F500 has a density nearly 100 times greater than that of water. The response time is critical to prevent greater risk, higher intensity fires, and provides a 24/7, 365-day protection and intervention when the facility is unmanned. A lot of these fires tend to happen after hours, where there is no human to be able to engage at a site level. So let's take a closer look. Heat detection using military-grade cameras, pinpointing hotspots. Often before a fire flares up, and advanced analytics eliminate false alarms. HD cameras and human verification and intervention, instantly alerted of a heat increase. The live monitoring team engages Fire Rover's automated suppression systems. Once these systems are installed and operational, they are 24/7 monitored from Detroit, the US, by a large control center. And the operator is controlling the use of the water cannon to engage the system to suppress the fires. It's a very unique system. It's the only type in its world for human verification of positives or false positives before they engage to suppress any fire. It effectively works on the hotspot of the fire using water and 100% environmentally friendly encapsulating product. And we notify our site contacts and the authorities should they be required. So you're paying for, and the facilities using the fire-over system not as a fire protection and fire suppression system, but it's an asset management tool. It is protecting a lot of assets. In the US, Fire-Over US has over $2 billion in assets under protection with their systems. And it is growing for us here in Australia. The system works 24/7, 365 days per year. And the results from the US are astonishing. With over 600 installed across the industry, US and Canada, with leading waste companies or waste and recycling industries, the proof is in the pudding. Across these 2,800 incidents, there was actually no major financial loss recorded. And as you can see from this data, the fire-over system is being confirmed to be used to mitigate hotspots per year only 9 times per year. Unfortunately, we don't have the same level of data as yet in Australia. It's estimated by Fire-Over's Ryan Fogelman that we will see significant increases in total known fire incidences across the world. And here are some numbers from the US. 2023, just under 4,500. This year, we're expecting 5,800. And 2025, just under 7,400 incidents based on trends. As we discussed earlier, with 300% growth in lithium-ion batteries each year by 2036, we are sure that we will see increase in fire incidents. It is the speed in which we detect and respond to these incidents that is crucial. Finally, as you can see here, to go with other global awards, Wastech and Fire-Over were recognised. We were recognised at the at the Fire Australia 2022 conference and trade show, taking out the Innovative Product and Technology Award 2022 at the Fire Protection Industry Awards night. To cap off today's discussion and on the increased risk of fire due to lithium-ion batteries, it is critical to point out that the amount of lithium-ion battery risk is real and increasing each year. As Zoltan included in his presentation as well, we need to educate consumers and businesses alike to recycle these products correctly. And prevention is unlikely, so we need fast, accurate detection, human verification, human intervention and notification to on-site resources, authorities, should further assistance be required. Thank you.
We've got one more speaker. Thanks, Scott. That was an incredibly comprehensive expose on the issues. We're going to move track a little bit before we come back to questions. I'd like to introduce Karen Davids, who's going to talk to us about circular intervention for medical plastics, so really zeroing in on the problematic waste of medical plastics. Karen has expertise in upstream circularity, notably avoidance, reuse and repair, conducted significant in-depth research around barriers and opportunities for the council community, and we're looking forward to hearing her perspectives.
Hello everyone. Let me adjust that, I'm quite short. All right, so yeah, we're changing tune and we're going to be focusing on something that is a very different problematic waste stream, but incredibly pertinent as well. So medical plastic waste, I think the first place to start in terms of our thinking is considering how it's tremendously grown since the COVID paradigm, as you can imagine. So that's kind of to position the context of our discussion today. But before I really dive in, 2 things I want to address. Firstly, this is funded by New South Wales EPA, and it's been such a valuable project because there's not enough happening in the space considering how big of an issue this is. And secondly, I am presenting on behalf of my former colleague, Rebecca Larkin, who now works at New South Wales EPA, actually. So if you have any specific questions that I might not be able to address, I'm more than happy to pass it on to her. And I've also left her current work email on the last slide, if you guys want to directly ask her anything. All right, let's jump in. Okay, so let's just consider firstly, what is medical plastic waste? We want to think about it in terms of soft plastics and rigid plastics. So soft might include things like aprons, plastic bags, and packaging. And then in terms of rigid plastics, you've got things like disposable bowls or kidney dishes. And then we can think about categorising it into clinical waste, which is a small percentage, and then general waste, which is significant, and we'll look at the stats soon. And just to understand really the differentiation between those, so clinical waste has come into contact with potentially infectious material and must be incinerated or autoclaved before disposal, while general waste, as we would all be very familiar with, has not been in contact with infectious agents or hazardous or radioactive substances. Okay. Cool, so this is just now referring to some of those stats I was briefly alluding to. So let's just think, what is really the scale of this problem? Firstly, healthcare, as we can see by that first black triangle, is the largest generator of waste in the New South Wales public sector. And as we can see in the last black triangle, plastic comprises between 25 and 48% of this waste. Then second, disposal is estimated to cost over $10 million per year. 12 of the 15 New South Wales local health districts generated over 24,000 tonnes of waste in just 1 year. And the last key fact that really draws out, I think, the true impact of this waste stream is the fact that 79% is currently going to landfill, while only 10% is recycled, and then you have 4% which is incinerated, and that's just clinical waste. I might also just add, actually, to that kind of contextual picture, there's also a major misclassification of medical plastic waste. So that comprises, it's a big range, but anywhere between 33 and 90% of the clinical waste stream, which basically suggests that more waste could be avoided or recovered from landfill if it were classified correctly. And viable reuse or recycling pathways, therefore, could be kind of strategized or considered collaboratively with some of the stakeholders that I'll mention. All right, let's move on to the next one. Yeah. Okay, so as a result, MRA was engaged by the EPA, as I mentioned before, to really try and unearth some more data in this space to understand with a little bit more accuracy, the scale, because a lot of those numbers are based on limited research, so we want to kind of, corroborate those studies as much as possible. And so we had 3 key objectives, the first of which was to assist medical facilities to transition to circular economy outcomes for plastic waste specifically, 2, to actually research and then trial some of the innovative methods we identified from international case studies, and then 3, to identify system-wide mechanisms that would support a long-term transition towards upstream circularity. Perfect. Okay, so now let's consider how we put these objectives into practice. So talking a bit about that method. So firstly, we undertook extensive desktop research on the best approaches to medical plastic waste avoidance and reduction. We also reviewed previous audit data in this space to just develop a baseline from which we could understand potentially the impact that our trials had once we rolled them out. Secondly, we consulted with healthcare practitioners and hospital sustainability staff to understand both the barriers and opportunities for enabling circularity within the healthcare sector. And I'll just also add, that included multiple site visits to different hospitals in New South Wales to get that on-the-ground understanding and really have that kind of deep listening approach to the stakeholders involved. Thirdly, we developed and trialled 3 interventions that I'll look at in a moment that focused on a number of actions within the expanded waste hierarchy, notably reuse, recycling, and reduction. And then from there, we measured the impact of our trials with input from a healthcare advisory group that we helped to facilitate as part of the project. And that was really from there to understand, again, for that third objective, the long-term mechanisms that would enable greater circularity. Okay, so I think it's important to just understand first, what are some of the real barriers that create, I guess, a lack of, or some stagnation within the space rather than propelling towards more circular outcomes. The first one is that there is, as you can imagine, a preference for single-use plastic items within the healthcare sector. As we would all imagine, this is largely due to the belief that disposables reduce the risk of infection, in addition to the perceived effort and cost of sterilisation associated with reusables, and both very, very valid concerns. Second, there are inconsistent waste systems and education in hospitals, and therefore only some recycle effectively, if at all. And just to bring us back to that original context I laid out, remembering that the statistic was only 10% of that waste currently tracked is recycled, so it is incredibly small. 3, there is a lack of access to recycling services, which just leans on from that point I just made, particularly for regional facilities. So collection services for reuse and recycling interventions are typically more accessible, as you can imagine, as well as cost-effective in metropolitan areas, simply because there's a higher density of businesses and waste. 4, the complex network of staff at healthcare facilities means that there's often a disconnect between the procurement of single-use items and actually the consideration of their end of life. So, that includes the disposal costs. Additionally, it was reported by numerous stakeholders that there's a number of staff shortages, particularly, as I was saying before, from that COVID paradigm, continuing burnout. So they've limited resources, human finance, to really implement some of these initiatives and make them long-term. But it's not all doom and gloom, as I'll explain. And then lack of data, once again, which is what this project's trying to address to some extent, as well as limited space within hospitals to actually implement a bin in order for source separation, and as well as creating a centralised waste storage area. As you can imagine, they're going through a lot of materials per day, considering it's predominantly single use. Okay, so this is the exciting bit, now that we're over all the sad parts of the story. The first bit is ice brick reuse. This is a really exciting one because, once again, as I probably made it very clear, MRA is quite an advocate of upstream circularity, so reuse is really one of our first port of calls. And just for a little bit of understanding around ice bricks and what they're used for, in case people aren't across all the different medical aspects, it's just to keep the vaccines and other medicines cold, which obviously is incredibly important. Then, in terms of where we applied this, we did apply it to multiple hospitals across New South Wales, so it did have quite a bit of an impact that we could measure against. Second, we implemented reusable hollowware in theatre rooms where surgical operations are undertaken, and this was trialled at just the Prince of Wales Hospital. And then third, we implemented source separation, baling and recycling of theatre plastics, which was also trialled just at the Prince of Wales Hospital. Okay, so this is a fun transition into what circularity can look like. So basically what I'm showing here is the linear system for procurement, use and disposal of ice bricks compared to the circular system we trialled, which you might call a reverse logistics system. So essentially how this worked was that we identified New South Wales health pathology laboratories located at hospitals across the state, reported that they do receive a large quantity of ice packs for cold deliveries, majority of which are disposable, and they consisted of soft plastic material, but some of the ice bricks were actually designed for reuse and were made as a result from strong rigid plastic, but unfortunately those were still going to general waste because of a number of barriers I've already referred to. So to really take advantage of that reusable piece of the kind of story, I guess you could say, MRA co-designed and implemented this reverse logistics model for collection, cleaning and redistribution in collaboration with the health pathology labs across New South Wales. So that was a big feat and something that I think has had really successful outcomes, which I will look at in a moment. But I also want to just outline in a bit more detail, I guess, how we facilitated that approach, because it is quite complex. So we first collected data from 8 health pathology labs on the type and quantity of ice brick waste generated. The average lab we found was disposing over 140 ice bricks per week that had the potential for reuse. And then MRA reached out to the supplier of the ice bricks that we can see here in the little circle, to discuss the potential for collection and cleaning. And then essentially the discussion panned out that the supplier didn't want to pay for transport to collect reusable items, since the stakeholder didn't believe it was necessarily within their responsibility. However, they were open to cleaning any of their own brand of ice bricks that were brought back by the labs themselves or a courier system. And so from there, we basically spoke to New South Wales Health Pathology Laboratories about how we could maybe facilitate that one opportunity, and we were able to leverage their existing courier system where they had some empty space on trucks that were making deliveries already, and we basically implemented that, and then we brought the reusable ice bricks to Westmead Hospital that was very close to the supplier. So then we could consolidate them at Westmead, like packaging wise, and then send them off to the supplier to be cleaned and then redistributed. Okay. So let's just look at some of those outcomes now that we understand the process in a bit more detail. The trial ran for approximately 8 weeks and across those 8 labs, and within that time, 33 deliveries of ice bricks were made to Westmead Hospital, and a total of 1,096 ice bricks were delivered to the supplier for cleaning and redistribution. So this diverted over 1,000 kilos of ice brick waste from landfill. And then importantly, we also found in terms of scaling the impact, which is I think the really important piece of the story, is that if this trial was to be expanded to all 60 labs in New South Wales, this intervention could divert approximately 61 tonnes or 51,000, it's a lot, ice bricks from landfill each year. Okay, let's do the next intervention. So this is reusable hollowware in theatres. So how we embarked on this was a similar process. It was a very collaborative co-design, methodology. And we rolled out this trial with the staff at Prince of Wales Hospital because we first wanted to discover the contents within pre-packaged surgery kits, such as bowls, kidney dishes, and galley pots, but also to understand, how much is being disposed. And basically what we found out, which I guess isn't shocking, but even if they open the surgery kit and not everything is used, everything has to go in the bin. So it's about the idea of, how can we salvage materials that are in a fine condition within that particular context. So as a result, the theatres department generally fill up 1 to 2 660-litre bins of hollowware each day, which is equivalent to approximately 80 kilos of waste per day for just that one particular practice within the hospital. So to avoid this waste, we did procure reusables, sterilise them on site because the hospital, and this was part of the reason we selected it, already had that sterilisation capacity. So I think that's something important to think about if you want to trial something like this as well. Start with the kind of low-hanging fruit. And then we packed it into custom surgery kits because we knew from speaking to the theatre nurses what they probably would need for the majority of surgeries that were booked in. Okay. I might just talk us through some other details in terms of method, because again, it is quite complex and it's valuable to think about all the different, moving parts. So the Central Sterilising Services Department at the hospital were actually the ones who consulted the nursing staff to determine the ideal configuration of the packs. And that's because obviously we couldn't go in and make that decision directly because we're not the expert. So that's why I'm saying co-design constantly is just so valuable. Then following, the department prepared and sterilised the major and minor surgery packs. And additionally, and this is quite an important aspect, they added barcodes to the reusables so we could really track how many were flowing through our reverse logistics system. And then, as you can imagine, lots of education was taking place. And then finally, in terms of washing, we did rely on the theatre nurse to place it on a trolley, which would then be taken to the sterilisation area. And from there, they also actually manually would fill in a data sheet that could basically have like a data conversation with the automatic barcode system that was tracking the cycles as well. So as this outcomes list shows, the trial ran for 8 days, which I do recognise is incredibly short. However, due to the successful outcomes within just that period, the hospital did actually decide to continue it, and it's kind of a no-brainer considering that they already had the reusables and the sterilisation and the training going. So I guess it's not really a trial per se anymore. But during the 8 days that we did actively call it this pilot, we diverted 328 single-use plastic items, or 16 kilos of plastic waste from landfill. And we found that if this intervention were to be expanded to 19 theatre rooms in just the one hospital, approximately 148,000 items, or 10 tonnes of plastic waste could be diverted. Okay, finally, so third intervention, source separation, baling and recycling of theatre plastics. So typically, I guess, to again paint the picture, because it's a different part of a hospital, typically waste generated in theatres is stored in the theatre waste room before being transported to the centralised loading dock for collection from their contractor. So then every day, multiple trips to the loading dock are required, just simply because the amount of waste generated, which you can imagine is incredibly time-consuming. It's not the most efficient process. So for example, as we can see in this pink box, theatres at Prince of Wales Hospital generate approximately 6 1,100 litre bins, or 48 kilos of plastic waste each day, which is all sent to landfill. Some examples include device packaging, clear soft plastics, blue sterilisation wrap, and syringes. And this waste stream, interestingly enough, is actually mostly clean, as it's not contaminated with blood or potentially infectious liquid, hence why there's a capacity to potentially clean it. And I think it's also important to think about how many of these items actually are suitable for specialised recycling. It's just there's a lack of conversation within that space about how to kind of leverage the infrastructure that already exists in the market. Okay, so some of these pictures will be much more helpful for understanding what this system looks like, because I recognise, I think this trial is a bit more of the complex one out of all three. So again, co-design, MRA collaborated with the hospital's sustainability manager to organise a recycling service for the source separated plastic waste and to install clear signage, which we can see there, to really help the theatre nursing staff and others who were transferring the waste, like the operators, to the loading dock. And then MRA assisted the manager to also apply for a bin trim equipment rebate because that fell within the New South Wales EPA funding that we were running the program within. And that helped to cover some of the cost of the 2 plastic balers that we can see illustrated there. And then I think, 3 key takeaways from this is that we found both baling and recycling the plastics in the theatre waste room itself, improved storage capacity in the theatre rooms, improved workflow as less trips to the loading dock were required, and reduced contamination and other recycling streams in the loading dock because it kept it all clean and separated. Then in terms of numbers, so diversion impact, since installation, the hospital has diverted 240 kilos of plastic waste per week. And if we scale this up to a year, there is a potential to divert 12 tonnes from landfill. As a result of these numbers, the Prince of Wales, and also just the fact that it's ran quite smoothly, currently exploring options to expand this trial to other departments on site, and they're talking to other hospitals in the state about the potential to also, replicate the methodology. Okay, so finally, if we think back to Objective 3 of the project, which feels like a while ago now, we want to explore mechanisms for engendering long-term change towards that upstream circularity within healthcare. So we recommended a few different steps in order to achieve that. first off, was developing a statewide waste and procurement data framework for hospitals that encourages a consistent approach to reporting, because as I've touched on, a lack of data as well as a lack of consistent reporting practices means it's very hard to understand, you know, the true kind of reliability of some of those statistics we were referring to in the first few slides. And then from there, we can really understand what opportunities lie on the horizon that may have that greatest impact within the locale or the region you're looking at. Second recommendation is that state government and hospitals could advocate for suppliers of medical products to redesign for reusability and recyclability. And I think a prime example is really redesigning those surgical packs to ensure hospitals only have the type of plastic equipment they really require. And that pre-planning process, as our trial illustrates, is actually very much possible with the right level of consultation. 3, develop best practice procurement guidelines, such as sustainability criteria or a procurement decision tree, such as the bespoke design MRA created, that prioritises reusable and recyclable products. So basically, as you kind of you sift your way through it, you get this very nice guidance as to, you know, if you have this practice, if you don't, what's the viable next step? And then if it is viable to pursue the recycling pathway, for example, it will highlight to speak to your suppliers, etc. Then we've got 4, advocate for increased transparency of item specifications, such as the plastic polymer type. So, you know, people within the healthcare sector can really understand the recyclability of those materials, as well as that important education piece that would have to come with it, because they're not necessarily experts of plastic waste. And then 5, develop a consistent approach to recycling across hospitals to reduce the resources expended when these systems are developed in silos, which I think is quite evident from the case I'm presenting, that it is developed in silos and at very small scale. So I think as a final note, let's think about the scalability of some of this. So in terms of a number, we can think 83,000 tonnes of plastic waste could be diverted per year by only a few hospitals, so the ones that were engaged within these 3 trials. And then in addition to that, if those few hospitals continued over the year, those 3 trials, they could also divert 500,000 single-use items from landfill approximately. So there is significant potential for change, and I think it's just about having a conversation of how we can facilitate this in other states potentially, and other healthcare departments within New South Wales. That's it. There you go. No worries.
Well, 3 quite different but extremely interesting presentations. I thought there were a couple of common themes, actually, surprisingly. Data, obviously, a really important one for all 3 of you. If you're really wanting to make a difference in some of these challenging spaces like hazardous waste, then having that data background to inform your decisions is an essential piece of the puzzle. Do we have any questions from the floor?
Sorry, just a second. Just wondering if you looked at the impacts on the operational staff, and you know how having to change those processes impacted them. I'm coming from, my son's actually a theatre orderly at Adelaide Women's and Children's Hospital, so is often talking about how much, you know, time and effort that they have to go around through this stuff. So
Yeah, absolutely. I mean, I'm no expert in terms of the operation side, but based on the consultation results, we know that all of this is relying on their extra time. It's just volunteering essentially, because they're already, as I highlighted in the barriers, burnt out and there's shortages. So look, I think there's CE champions, as we like to call them, within different sectors, and a lot of the theatre nursing staff that we engaged, or we had like anecdotal evidence passed on through the sustainability manager, are really passionate about the fact that there's so much waste generated and they want to do something about it. So I think there's just a few that maybe, despite existing operational practices that might hold them back from doing this at scale, are still trying. Whether it's viable at scale is another question, but I think it's worth having that conversation. Yeah.
Karen, thank you for your talk. I agree with you. Hospitals are extremely wasteful. Spent 8 weeks in one some years ago. But unfortunately, the last thing on a nurse's mind after 14 hours on their feet and being spewed on or abused or whatever is to sit there and say, should I put it in bag A, B, C or D? Probably requiring extra feet on the ground to do it. The hospital system is broken. People waiting for up to 8 to 13 hours in the emergency centres. I don't know why it just doesn't go to be burnt for power and short circuit. I think it's a lovely idea, but sometimes you've just got to say, you know, we can spend our time and resources better. Just a comment, not saying you're wrong, but that's just about the whole situation. Over.
Yeah, I recognise that it's a comment, but I will comment. Look, I think you're touching on energy from waste, which is a whole other beast, and we've touched on that, and there's been a panel on it, which I wasn't able to get to, but I'm sure it addressed many of the concerns of that and the limitations and, you know, the lack of infrastructure for that particular model within Australia. I'm not going to kind of conflate that with this, because I think they're two very different focuses, and I also think if we come back to the objectives of this project specifically, it is upstream circularity and energy from waste is downstream. So whilst they both have a place, I think for different types of waste as well, I think it's about just, once again, distinguishing between the two different parts of circularity and recognising that they have to work in tandem to some extent. But first, let's think about the material type or the plastic polymer and then decide, you know, within the kind of constraints of those different materials, recyclability or reusability, which practice can we pursue that potentially is upstream first before we consider that last option, which is at the bottom of the waste hierarchy.
I think with batteries, upstream's quite important too. Zoltan, you spoke a little bit about battery quality. How do you see that impacting the risk profile of batteries?
So we have an economic problem here, right? So where the upstream recycling is going to come in is on the larger batteries, particularly EVs. EV batteries are considered end of life at about 70% of their capacity. At 70% of the capacity, there's nothing wrong with the rest of the battery. You can still deploy them in energy battery storage. You can make use of them in all sorts of applications, from, you know, camping equipment to backup batteries or whatever. So we have just commissioned our first official decharge station that's able to give us some diagnostics on the EV batteries, and that will allow us to make some decisions and determination if those batteries are suitable. There's a number of companies who are involved in that space. So we have now located a potential and upstream scenario. We're working with one of the major OEMs to give us the green light to upstream the batteries. And as we're going down, batteries are becoming cheaper. The technologies are becoming more outdated. It's very difficult to find a home for a second-hand battery that is, you know, perceived to be heavier, bigger than what you can buy. But anything new can be reused. Thank you.
Other questions? I've got one for you, Scott. I was just fascinated to see that the observation of fires was happening from the US, even though the technology is here. Is that really what you meant?
That's correct, Libby. Yes, it's a very unique system. We're the agent and distributor for fire over in the US, for Australia and New Zealand. And in partnership with them, we assess a customer's site, first of all. We always provide a design that will give them ultimate coverage of their facility. It's up to them to determine their high-risk areas for the installation. Once we finalise the design and then we implement the system, the container system that you saw, which is a 20-foot container, is one of the solutions being offered currently. There is another system called continuous flow. The difference between the two systems is a container system is independent. It has its own water supply. It has a water tank internal. The continuous flow system is moving away from a 20-foot container for the installation to an electrical cabinet that manages the electrical and the water requirements, tapping into the water supply currently at your site. So you have unlimited supply to fight fires. Once we install the system requires network requirements, which is a dedicated static public IP address, and that gives 24/7 connectivity. And once that is commissioned by the Wastech team in conjunction with Fire over in the US, that then switches over to live monitoring. So Fire over in the US is based in Detroit, Michigan. They have a large control center, which we call Central Station, and they have operators managing and monitoring every camera of every system worldwide 24/7. There's various alarm protocols set up with the thermal cameras, and they detect different variations of heat, which will set off different alarms. And that will then indicate the process that we need to then follow of engaging the system ready for suppressing fires. But it's very unique. So the operator in the US, like you see on the movies, a drone operator, can be in any room anywhere in the world. The operators are managing the high-definition camera on the water cannons to direct the location of the cannon to suppress that fire.
It's quite an incredible service, isn't it?
Hi everyone, lovely presentations. My question is for Zoltan. You mentioned that you have estimated the expected rise in the lithium-ion batteries for the next few years. I'm just curious about the new waste streams like the e-bikes, the solar panels, if you have an idea about those. If you have an estimate for the EVs, you did mention about the EV collection container, etc., but do you have an estimate of what rise are we expecting in the coming years?
Very good question. Probably the answer to this is that if you read anything that's more than 6 months old, it's going to be outdated and likely inaccurate, right? The growth rate and the adaptation curve for EVs has surprised everyone. Those data, detailed data is, for example, available from drive.com, who actually logged the application of EVs and the uptake, right? As far as batteries is concerned, it's very much, I'm relying on research that the Battery Stewardship Council is normally offering. We are keeping track of the waste disposal percentages through the collected batteries as such, so it's very much lagging behind in time, but the adaptation report is publicly available through the Battery Stewardship Council.
And that's on the bcycle.com.au website in the resources section. Yesterday there was a suggestion that perhaps we needed a container deposit style approach for batteries, and it's certainly something I feel very concerned about because I really don't believe we should be encouraging people to hoard a dangerous good before taking it in for disposal. But nonetheless, Zoltan, I'd perhaps ask you to comment on the financial viability of such an approach.
There is a number of problems. As far as technology is concerned in developing a similar system to the bottle deposit scheme, for example, in theory it could be done. My big problem with that is that we have no idea on how I would reward a consumer to give them their battery back. The technology, is expensive to make that happen. And we are introducing a risk profile that maybe is not going to be suitable to sit right next to a bottle deposit container. A lithium-ion fire in an uncontrolled circumstance where we would collect specific chemistry, for example, is highly dangerous. And that will then arise with the question, okay, how are we going to contain the fire should there be one? So we're introducing additional risk for not a lot of reward. If we could motivate customers to bring the batteries back through the current system, I believe we would be much more successful in trying to put 10 cents on your batteries. All what you're doing is getting your 10 cents back that you have paid in the first place. So if you're really into recycling, you're going to get your 10 cents back. If not, well, it's lost anyway. Right? On batteries, it would be very, very difficult. How much would I have to give you to make it worthwhile to bring me back a AA battery? 1 cent? Is it worthwhile to come back? It's not, but the costs are huge to put that into a national scheme.
Thank you. Just coming back to your question down the back.
Question for Zoltan, Richard Plant from Recycling Victoria. You indicated, I think, in your presentation that around 14% of batteries. So the limitation for your company is the lack of deposition of batteries into the system. Could the system cope if you were, say, to introduce a competitor into the market in a halving of that and a reduction to 7%, I've got a selfish interest in looking at service continuity, particularly for battery recycling in the Victorian context.
In brief, there is a number of developments that are going through and in conversation with Sustainable Victoria, for example, and a number of other state government organisations, right, to enable capacity building. The current capacity for the processing is really not limited on the collection side. Because the system is automated, it's the frequency of pickups that's really becoming just an issue of, do you have 2 trucks, 5 trucks? There's currently about 84 trucks available within the group. Not all of them are associated with the metal recycling or the e-waste or the batteries, right, but they can be just interactively used right through. We have dedicated battery collection trucks which can be multiplied into, you know, any number. As far as the processing capability is concerned, it is a concern at this stage. However, there's plans in place, so there's going to be a major change over the next 2 years, and we're going to have excess capacity. We're unfortunately going to have that problem that we need the batteries, and the batteries are not growing at a fast enough rate to come through the system. There is multiple problems as far as regulation is concerned and the financial model that needs to be addressed. We need to include all the free riders, we need to include all product groups, because at the moment it's only really the loose batteries and e-mobility and power tools that are included. There is a whole other section to the market to address. And
just talking about e-mobility, because I think it's particularly pertinent to this topic, given that there's a higher degree of fires in that space. E-bike batteries are in B-Cycle's scope, but it's something that we've only just started to launch into, and I think we've been working on it probably quite dedicatedly for about 4 months, and we've got 3% of the market involved, and so it takes a long time and a lot of energy to bring free riders into these spaces, and so we've really been working to advocate for regulation, and that's in the battery space, given the increasing risk profile of these products, but focused on participation. So, you know, people who are bringing these products into the country are required to join the scheme. All right, well, fascinating presentations from all 3 of you. Thank you very much, and thank you for the great questions.